thank you for having me give the closing keynote here. I've been here, this is the 17th year. This is the first time I've given a keynote. So we'll see how this goes. The keynote topic I have is development tools, past, present, and future. And we'll see, I have a lot of history and hopefully some interesting ideas for the future. What do we want from development tools, really? What do people want from development tools? We want tools that help us write better software more efficiently. We want to write better software faster with less effort. Okay, blinding glimpse of the obvious, I know, right? We don't want tools that will make it harder. We don't want tools that make us slower. We don't want any of that. We want tools that make us more efficient and let us write better software. I have a picture of one such development tool. Has anyone ever used one of these? Does anybody know what this is? Yoda. A long time ago in a galaxy, well, right here. For those of you who've never seen this is a paper tape splicing kit. You have paper tape that you fed in through a reader to load data into a computer. This has a holder that you can put over the tape so you can punch additional holes. You can edit the software. It has a knife that you can splice it. It has tape that you can join two pieces together. You can snip out erroneous code. You can splice in new routines and then punch them out. What?
Cut and paste.
Cut and paste, you bet. Tape, it's got tape. Yes, I won't say that this is where cut and paste came from because I really think cut and paste mostly came from the newspaper photography industry, but that's okay. Cut and paste.
I'm personally responsible for introducing the term splice to Alex CppNow.
There you go. Okay, so this was a long time ago. This is unique for me as a software development tool, which is not software. But I'm not going to talk about things that happened before many of the people in this room were born. Most of the people in this room were born. I'm not going to talk about teletypes. I'm not going to talk about acoustical modems. I'm not going to talk about Hollerith cards. I'm going to kind of skip all over those because, I could talk for hours just on that and get up to, 1970 or so, but that's not really that helpful. It's interesting. It's interesting to me. It's probably not as interesting to you. Okay, so we'll start at 1970. The 1970s and 1980s. We're going to talk about a bunch of things that happened then, because that was a great time for software development. It was the time when we first started seeing the first personal computers that didn't take up a room or, heaven forbid, an entire data center. It's time when the access to computers basically exploded. You didn't have to, go work for IBM to get access to a computer or DEC or somebody. Just a word of caution for all of this talk, I'm going to kind of divide stuff up into chunks, and I'm going to give them dates like this. And these dates are approximate-ish. I might talk about something that happened in 1969 and pointed at 1970s, okay? In the 1968, 67, 68, 69, we had a software development project that was, in fact, amazing. It's amazing to me now, 50 years later. Who knows what I'm talking about? I'm talking about the software that ran the Apollo project, right? Both the ground control software and the software on the spaceships. This was an amazing feat of software engineering, and it was done with tools that you would turn your nose up with today. I can't write software with that. And yet they did. Anyway, 70s and 80s. Let's go with that. The first that I'm aware of, it's not the first one, but the first one that I was ever aware of in terms of programming tools packaged up together was the Programmer's Workbench, which came from Bell Labs in 1977. It contained an editor, not an editor you've ever heard of, a compiler, compiled the language B, It contained a linker. It contained a very early shell. It contained a program called Make. I was reading up on the history of Make just this last week. It was some people at Bell Labs. Somebody came walking into one of the engineers' offices at Bell Labs complaining that he'd just blown an afternoon trying to track down a bug in his program when he just realized that the fact is his program was not broken. He had just forgotten to recompile this source code. And so he'd been linking against object code that was an earlier version of his source code. And the guy he was complaining to said, yeah, you know, I've had that problem too. I mean, I've had that problem. I remember my first job right out of college, we worked on a system that didn't have a make. And so we had that problem. Oh, I'm linking against an old version. And so the guy sit down, I can't remember his name, but you can Google it. What?
Stu Feldman.
Stu Feldman, thank you. You know, sat down one weekend and wrote make. What also came out of this was source control. Source control systems, SCCS was the first one, and various ones came afterwards. This was a great boon for people. Excuse me, I woke up this morning with a bit of a sore throat, so I'm going to be drinking a lot. And those were all part of the programmer's workbench at various times. There were many releases of it. Visual editors. There was a visual editor here. Visual editors became very widespread in the 70s, which was, how many people here who have edited stuff on line-oriented editors or teletypes? A few, yeah. Nobody wants to go back to that, right? Nope. And this bottom one here is not actually something that came out of Programmer's Workbench, but there were lots of implementations of virtual memory, specialized virtual memory for small machines, because most of the machines that people had were pretty small. And people were writing pieces of software where the software and the data couldn't really fit in RAM on these 8K, 12K, 16K, 32K, 64K if you were really lucky machines. And so there were ways people had these amazing hand-maintained systems where you split your object code up into self-contained chunks and your program would manually load them and unload them as you needed a particular kind of functionality. For example, say you had this big module which for printing for your, say, word processor. And the printing lived on your disk, floppy disk. And when you said print, it loaded that up and showed you dialog, and captured your settings, and then went off and printed. But until you printed, there was no printing code actually in RAM. And this was important because RAM was small. Anyway, there were also virtual memory systems, again, homegrown virtual memory systems for paging in and out data for various things, databases or whatever. Anyway, this is about when I graduated from college, and I thought this was all pretty darn cool. Okay, later, we got things like integrated development environments. The things, a compiler and a linker and a debugger and an editor all packaged together, and that they knew things about each other. And this was a big leap forward in productivity. Turbo C on Windows was an example of this. The Macintosh Programmer's Workbench, which I think was 1986. Think Pascal, which was 1984, again on the Macintosh. I started programming Macintosh very early, so a lot of examples are going to be from Macintosh history. Xcode, Visual Studio, CLions, CDevelop, many, many more. I could fill up an entire slide of dense text of various integrated development environments. But we have them with us today. Most people use them today. I don't know whether you use Visual Studio or Xcode or I'm spacing on the name of the one on Linux, but yeah. Anyway, no. Emacs is not either. But Emacs can be made to behave very much like that. Yes, Emacs can do anything, I know. It's useful, it helps you manage large projects with multiple files, with multiple kinds of input files, not just text files. Programming projects these days, and actually by the 1980s, it contained, if you build an application, it contained artwork, it contained structures for your user interface, it contained all sorts of things. Yes?
Is Eclipse in the 80s or later?
Eclipse, I think, was later than that, and thank you. That was one of the ones I thought about, Eclipse. But anyway, manage multiple file projects. Manage the dependencies. Gather the information from the user about what files go into the final release. The final deliverable. So we moved away from executable to deliverable because sometimes it's the thing you actually are shipping is much more than just a single executable. It might be an executable, and some shared libraries, it might be man pages. These days, it's a whole collection of stuff. On macOS, it's called a package, and it's basically a special kind of directory. Manage multiple file programs, manage configurations. This was a big deal, too. Being able to just push a button and say, I want to debug build, debug build, debug build, debug build, and then finally release build. Building an English version, building a Spanish version, building a German version all at once. And also, as part of this, we got language-aware editors. We got editors that did syntax coloring. Woohoo! I'm trying to remember the first time I saw this. Anybody want to say? It was the 1980s, but I don't remember when.
I think Pascal had something like that.
Oh, think Pascal?
It wasn't color because it was black and white screens,
but bold and italic. Okay, Lisa says that Think Pascal was shipped in 1984. Had this. I'm sorry, I didn't hear what you... Okay, Norton. Excuse me. Turbo C2, which was probably what, 87, 88, something like that? Anyway, jumping between definition and declaration. Multiple windows, yay, the whole Windows icons, mouse, pointer paradigm was been a big boon for software developers and everybody else. Syntax coloring and jumping between two, and being able to compare two files either automatically or on the screen at the same time, all of that. And so this was the 1980s. And at the end of the 1980s, I had just finished working for a little company in Oceanside. We were doing printer drivers for macOS, and I thought the development tools were really, really great. Then what happened? We started the 90s. What happened? CPUs got faster, lots faster. People started putting multiple cores on, or multiple execution units on a single core. We got many cores on a single computer. RAM got cheaper, no longer had to worry about, I had a big machine in 1980. It had 8 megabytes of RAM. And also, this is like, when did they start doing this? This was 2010, when Amazon and Microsoft and so on started basically having compute farms for sale. There were probably ones before this, but these are the ones that I know about today. But basically, the overarching thing is CPU cycles got much, much cheaper. Okay? Storage limits were much less onerous. But how did that affect developer tools? Well, we'll get to that. Networking became ubiquitous. All the computers came with networks, and then we got wireless stuff. And networks became faster. In 1992, I would have sold half of my soul for a nice gig E network. Now I have one in my house. Networking and source control are a match made in heaven. My first job out of college, first day of work, I came in, my boss sat down and said, here, this is your job for today. Thank you. And he said, I want you to write a piece of software that does this. Insert this additional functionality into this existing program. I was like, fine. I went off and I sat down and I read for a while and looked at this and asked some questions of people and sat down and wrote, 50 lines of code and compiled it and tested it. It was all good. And it was the end of the day. And I took the 8-inch floppy disk that I was working on and I put it in a desk drawer with my name on it. And I went home. I had had a good day. I'd accomplished something on my first day. This was great. And I came back 2 days later, because I was actually still in school, but I came back 2 days later and opened up the drawer, the desk I'd been working at. The floppy was gone. I went looking around and finally found it. Somebody else was using it. What's up? Well, I needed a floppy, and so I used it. It's like, okay, I spent all day on Monday writing code on that floppy. Sorry. I have worked since then. I have worked in offices where there is a master floppy, or later a master hard disk that gets passed around. If you want to merge, you go get the master hard disk, and you manually merge your stuff in. And then, when networking, and that's every bit as error-prone as you might think it is. And also, you have no history. And then, when networking became okay, the magic hard disk was switched to a magic folder on a server somewhere. But still, manual merging, and no history. And then we got network-aware source control systems. I used SourceSafe. I used Perforce, I used Subversion, and people had holy wars over which one was better. And my thought was, yeah, depending on what you're doing, one of them is better than the other, but any one of them is so much better than nothing at all. It's not even close. But source control systems and networking, match made in heaven. Anyway, okay. But at the same time, and this slide is my opinion, GCC made a wrong turn. May not have been a wrong turn for GCC, but it was a sad thing for the computer industry, especially the people writing software tools. Richard Stallman famously declared, GCC is a compiler, not a library. And what does he mean by that? He meant that they did not want to provide the functionality of being able to use the compiler in other tools. There's lots of discussions about this. You can go look up years of discussions. They're still having this discussion. But the concern was licensing issues and people writing tools around GCC and then maybe selling them. And you know how the Free Software Foundation feels about that. I'm sad about this because I think this set back the ability of people to produce, or just so I should say set back, retarded the ability of people to produce C++ aware tools for probably 5 years. Fortunately, Clang came along a decade later and explicitly repudiated this statement. Clang is all about. Clang is a bunch of libraries. LLVM is a bunch of libraries. If you put them together one way, it's a compiler. You put them together another way, it's a source reformatter. You put them together a different way, it's this or that or the other thing. And that's a great thing. But at this point, this was, I said, kind of a blow to the C++ tools industry. And people either sat down and spent a year or a year and a half writing a C++ front end that they could use in their tool. That's kind of a high barrier to entry. Or they went off and licensed something from, say, EDG, which is also a high barrier for entry for a small company. But there were a fair number of EDG-based tools out there. Okay. Along around the turn of the century, we got a couple of process improvements, things that became popular in helping people write software that were not strictly software development tools. And they were TDD and agile development, excuse me, not agile programming. A little bit before this, we had things like extreme programming and pair programming and so on. But these are the ones that, in my mind, made the biggest difference. So test-driven development was started by Kent Beck in 1999, was actually developed or popularized by Kent Beck. Basically, it can be summed up as have automated tests, keep them passing, run them a lot, over and over again. The key here is between running them a lot is having spare computer cycles, right? Keep them passing. The original manifesto of test-driven development was you write the tests while you're developing the code. The end game of that is you write a test, watch it fail, write just enough code to watch the test pass, refactor the code you just wrote, commit that, and move on. And the idea is that each step is 20 minutes or so, an hour maybe. And that you iterate over and over again. I have never been, actually, I don't find that to be that productive to me. I like to choose the chunks of work that I do, but I certainly develop tests while I'm writing the software. And when I check in a chunk of code, it always includes tests. Having a test suite that you are confident in is an amazing game changer, okay? No matter how you do this, 20 minutes at a time or a check-in, a clump of work at a time, or whatever, is a game changer. And I'll talk about that in a little while. Anyway, when you get a bug report, first thing you do, you write a test that duplicates the bug. Fix the bug, run the test, verify that it's fixed, add the test to your test suite. What does this mean? This means this bug will never come back. Or actually, that's not what it means. It means if the bug does come back, your test will fail, and you'll know it. Having worked on projects where I sometimes had to fix the same bug 4 or 5 times, big win. If your tests pass, your code is good enough to ship. Okay? That's the goal. That's an aspiration. And I have worked on projects where that's true, but some projects, especially things that say have to talk to external hardware, many configurations of hardware, that it's expensive, that maybe you don't happen to have lying around, but you have to arrange to have time on, they have extra considerations. But in general, the idea is if all your tests pass, your code is in good shape, and modulo, oh, I'm missing features, it should be good enough to ship. And the corollary, I never can say that word. The flip side of that is that if you're not confident enough in that tests passing means your code is good enough to ship, then your test suite isn't good enough and you need to enhance your test suite. Okay? Improve your test suite until this is true. I have worked on projects where this has been the case, and this is a really, really nice place to be. I will give you an example of a really, really bad place to be, and that is what I call fear-based programming. Some people know immediately what I mean by that. We go to somebody and say, I think this is wrong and we need to change it. And they say, oh, I wouldn't do that because it might break something else, something way over there. And it's like, I have a test suite. If it breaks something else, I will know about it. I have a test suite and I have source control. I can revert a change if it breaks something way over there. I had like 3 or 4 jobs in a row where they all practice what I call fear-based programming. And I don't ever want to go back to that. it's a terrible place to be, because every time you make a change, you're not thinking about, is this a good change? Is this a bad change? Is this going to help me? But rather, what else is it going to break, and how would I ever know? Anyway, another example of why you want a good test suite is code coverage. How do you know how much stuff you test? Well, there are profiling tools that you could run your test suite, gather it all up, and show that for each file, each source file you have, or each, well, source and, header and source file, it shows you all the lines in there and how many of them were exercised by your test suite. If you don't have a test suite, you're not going to get there. You can go, you look at your coverage report and say, oh, look, half of this file is not ever tested. And you write tests. I had that happen to me when I was libc++. When working on libc++, I found a header file in the library that like half of it wasn't tested. And so I spent an afternoon writing tests for that chunk of functionality. You know what? They all passed. There weren't any bugs that I found in that chunk just because they weren't tested. But now I'm more confident. Anyway, I'm going to talk in a little while about sanitizers. Sanitizers, again, are way better if you have a test suite. Okay. The other half of this, the process improvements that showed up in around 2000 was agile development. It builds upon test-driven development, builds on extreme programming. The idea is that you do incremental development. You plan your development in terms of what they call sprints, which is a word I don't particularly like because nobody can sprint all the time. You sprint for a month, and then you sprint for another month, then you sprint for another month. You're sprinting all the time. But always have a functional system, and the development projects tend to be short. None of this 6-month ongoing thing, and then at the end you say, oh, dang, that didn't work. The nice thing about short development processes is that if something doesn't work, well, you haven't invested that much time in it. Lots of communication between team members and the people you're developing the software for. For internal, that's your management. For external, it's customers, so that everybody knows what's going on. The joke about stand-up meetings is if you get meetings together and everybody has to stand up, they don't get comfortable, they don't have to spend a lot of time on it. Anyway, this has been, a lot of things in here have been adopted widely, and a lot of them have made really big improvements. On the other hand, what's the best way to say this? Some of the things remind me very much about cargo cult behavior. I was on a successful project once. I'm paraphrasing. I was on a successful project once that used agile development, and we had a stand-up meeting at 7:45 every morning for 15 minutes. So we should have a stand-up meeting every morning at 7:45 for 15 minutes. This worked. So, we did this and it worked. So we should do that too. Or they did this and it worked, and so we should do that too. But that doesn't have anything to do with the success, the time of the meeting or the actual length of the meeting doesn't really have much to do with the success or failure of your project. That's what I mean by cargo cult behavior. And the other thing is it's been a huge boon for the training industry. How many people in this room are certified Scrum Masters? Yeah.
How many people have to take classes with certified Scrum Masters?
There you go. Yeah, I saw more hands for that. If you're in the back and I ask you to see hands, I can tell you I can't see you because that light right up there is very bright. Anyway, yeah, take classes with certified Scrum Masters. Okay, anyway. On the whole, I think agile development has been a huge win for the for the software development industry. Excuse me. It has not been an unalloyed good, though. Okay, let's move forward again. The last decade. Okay, the last decade starts-ish 2014. And to my mind, this has been a golden age for software development tools, except that I want to push back on the idea of golden age, because usually when people talk about a golden age of something, they're referring to something in the past, and things are much worse now than they were during the golden age. And I don't want to give that impression, okay?
Don't worry, things will go downhill.
Anyway, the last decade has seen an explosion of tools to help developers. Okay, first page. And I'm sure there are tools that are not on here. These are tools that I'm familiar with and I have used. Sanitizers. Is there anybody in this room has not used any of the sanitizers, address sanitizer, memory sanitizer, thread sanitizer, uninitialized variable sanitizers, UB-san? Anybody? Who has not? Oh, that is a wonderful thing to see, because I can see no hands at all. That is a beautiful thing. These came out of Kostya's team in Moscow, working for Google, and many of them have moved to Santa Clara, excuse me. It takes me 3 times to get the right city out. And that has made an amazing difference to the software industry. 10 years ago, it was not really that hard to crash your browser. Now, you can still do it, but it's much harder. Okay, and if you go and read release notes for Safari, for Chrome, for whatever Microsoft is calling their browser this year. Anyway, for any of these, you read the release notes, and down at the bottom where it says, security vulnerabilities or bugs fixed, a lot of them say, mumbly, 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 found by address sanitizer, mumbly, 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 found by address sanitizer, mumbly, 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 found by address sanitizer. This is something that, again, is a game changer in the world. And sanitizers work really well with your test suite. The better your test suite is, the more value you will get out of running the sanitizers. Because if your test suite exercises more and more of your code, the sanitizers can see how it runs and find bugs. Okay, everybody's used them, so I'm going to move on. Fuzzing. Fuzzing was a thing 2014, 2015 was when it became widely available. There was an early library called American Fuzzy Lop, because somebody liked rabbits, and because his fuzzing, it was fuzzy. Rabbits are fuzzy, the library was fuzzy. How many people here have used fuzzing to harden their code? Good. Okay, about half. How many have not? How many are asleep? So basically what fuzzing does is you pick a chunk of your code that you want to exercise. And what fuzzing does is it generates random inputs. And you write a little bit of code that takes this random inputs and basically passes it to the piece of code that you want to test, and then it runs. That's not, okay. This is, again, a consequence of the fact that CPU cycles are really cheap, right? You can afford to spin up your cores overnight or for a weekend or something, throwing random inputs at your software. But the thing about AFL and Clang Fuzzer and several other ones is that they hook into your code, the code coverage results that you're, so that when they poke at your software, they can start to build up a map of your software where the flow control has gone. And when they pick a new input and it goes down a different path they will start to tailor inputs to try to test that untested path. So it's a kind of like a profile guided random testing, which is a really weird set of words to put together. Several years ago, I wrote a base 64 encoder decoder because I needed one that actually you could hand stuff to in chunks, basically a streaming interface. Base 64, basically you take 3 characters, you put out 4. So you have to have a little buffer inside the encoder that's 3 characters long, or 2 characters long. But it has some state. So I wrote this, and it's not very hard, okay? It's, half an hour of reading up on base 64 and an hour of writing code, and then, another hour writing tests. And I wrote a bunch of tests, and I tried it, and everything was good, and so I said, fine, I'm going to fuzz this. And I fuzzed it, and 2 minutes in, it crashed. It's like, okay, what's going on here? Looked at the last input. Well, that's interesting, and extracted it, and tried it. Put that into one of my test frameworks, and yes, it crashed there too. And then I could debug it and figure out what's going on. And it turns out I had typed a character constant in a string wrong. LNMOP. And so I fixed that. And then I ran the fuzzer again, and it went 5 minutes this time and crashed. And I looked at it, and there was another bug, and I fixed it. And then it ran all weekend. And so the first test I did was take the input, base 64 encode it, then base 64 the stuff I just did, decode it, and make sure I got the same output back. The second one was take the input, the random input, and base 64 decode it. Now, most of the time that's going to fail because it's not valid base 64. So I get to test all my error conditions, all my error handling. But if it succeeds, then I'm going to base 64 encode this and compare it to the original. Is all good. Thinking about this earlier this week when I was preparing for this talk, or last week when I was preparing for this talk, what I really should have done was I should have gotten another base 64 library, and as part of the fuzzing, compare the base 64 encoding with what the other library did, and make sure it's not only consistent that I can encode and decode anything, but also I could, I matched what another library did. But anyway.
Marshall, would it just fail if you copied input to output?
If you what?
If you just copied input to output? If the encoded was exactly identical to the input?
Oh, that's an interesting thing. I don't think that there's any transformation except maybe the empty string for base 64 where the input and the output are the same.
If there was a bug that all the library did was copy it input to output, would the test catch that?
Would the test catch that? No, and that's why you'd want to test it against another library. The comment was, if my library was a fraud, if all it did was copy the input to the output, would all of the fuzzing tests have passed? Yes, they would have. Yes.
So I want to add just like what you're talking about, the whole process you're describing, that's definitely fuzzing, but there's property. If you do property testing, it has a special thing that it does after. It basically does random input, and then once it finds the bug, it does a process they call shrinking, where they actually shrink all the input and rerun the test until it finds like the smallest set of options that actually does cause a failure. So.
Thank you, Jody. I wish I had access to that. People were, at some point, trying to fuzz, I was trying to fuzz, libc++'s regex engine. And one day, I got a bug report that said, this regex crashes libc++'s regex engine. And so I looked at it, and I tried it, and sure enough, it did. And then I started looking at the regex, and the regex was about 450K bytes long. And I posted this to Twitter. I said, look, I got this regex that crashes libc++'s regex engine, and I have to debug. It's 450K long. And Michael Case, where is Michael? He left. Good. I have his clicker, so I guess I get to take this home.
I'm still here.
Okay. He responded to me on Twitter, said, I used to think it would be cool to be you. Anyway, fuzzing and sanitizers play really well together. Okay, one of the things that address sanitizer or memory sanitizer or thread sanitizer does is it takes inconsistent bugs, a whole classes of inconsistent bugs, and turns them into consistent bugs, things that happen every time, right? If you overflow a heat block, is that going to crash? No, certainly not right away. Maybe never, but maybe 30 seconds later. But with address sanitizer, it's going to crash every single time at the point where you overflow the heat block. And that and fuzzing are a great combination. Okay, we saw an explosion in tools for doing source control. We have Git, which really wasn't in the last decade. It started in 2005. GitHub, which started in 2000, I forget. Anyway, in the early teens and was bought by Microsoft in 2018. This has made using source control much, much easier. Anybody can get a free account on GitHub. You can check your code in there. They will take care of it for you. If it's free, you have to do everything public. If you pay them a nominal amount of money, I think it's $10 a month, you can have as many private repos as you want. But you also get another backup, which is nice. My only concern I really have about Git and GitHub is that I think at this point they are a legitimate single point of failure for the software industry. GitHub has been so successful that there are not very many thriving alternatives. I wish there were. That being said, I use GitHub. I like GitHub, okay? And it got a lot of people away from the magic shared folder on the server for source control. And the fact that Git does not actually require a dedicated server, unlike, say, Subversion, was a big win. Clang Tidy is a tool that came out of the LVM project. How many people don't know what Clang Tidy is? Oh, good. It's a great place to write tools that check things about your program that the compiler wouldn't catch. Maybe you have in-house coding styles. Maybe you've identified a mistake that you see people making a bunch. It's not hard to write a Clang Tidy tool that catches something. My favorite Clang Tidy tool is a dumb Clang Tidy tool. It catches one very specific error that no compiler will ever warn about. And that is, imagine you have a function that takes an int and a float, or an int and a double. And you call it with a double and int. You write 3.0, 1. That's not illegal. That's not ill form. The compiler will take that 3.0 and convert it to an int, 3, and it'll take that 1 and turn it into a float, or double, 1.0, and it'll call the function. But it's almost certainly not what you want. So the Clang Tidy tool looks for functions that take 2 arguments, calls to functions that take 2 arguments, where at this call site, both function arguments require an implicit conversion. And then it says, what happens if I reverse the order of the arguments? How many implicit conversions does it require then? And if the answer is none, it will put out a warning that says, are you sure? Maybe you're sure, okay? Maybe you know that, yes, I'm doing this right, but chances are really good that you just got it wrong. Okay? Clang Tidy. Clang Tidy is easy to extend. There are hundreds of Clang Tidy modules that test different things. You can write your own. You can write your own for your in-house coding style. Clang D is a background daemon that provides language specific information to an editor, to an IDE. via IPC. It's really nice for doing, it basically, you can do interactive code formatting, you can do autocomplete, you can find, it's the back end for jumping between definition and declarations, and a bunch of other things. More things in the last decade. Matt Godbolt. Thank you, Matt. I hope you're watching because thank you. It's a tool he wrote for his own use that has, shall we say, escaped into the wild. C++ Insights by Andreas, a really handy tool for exploring advanced C++ implementations. Thank you. Implementations. Basically, how many people have never heard of or never used C++ Insights? More, okay. Basically, you can paste some C++ in there, and what it will do is it'll show you what the compiler sees. So it looks through auto, it replaces all your autos with the actual types, it replaces all your lambdas with the structs that the compiler generates, and it gives you equivalent code, but this is what the compiler sees. And if you're not really comfortable with lambdas or autos, it's a great way to see what the compiler is doing for you. And, or if you have some code that's just like, I don't get what's going on here. It's a nice way to strip away some of the levels of abstraction.
Godbolt links to it.
I'm sorry?
Godbolt links to it.
Okay,
So
Godbolt
the
links
code
to
into Godbolt, you can click a button.
Oh, okay. So thank you. Gaspar says that there's a Godbolt link to C++ Insight. There's a link to C++ Insights on Godbolt that you can basically take your code and say, what does C++ Insights think about this? Okay. Man, I'm learning something. This is great. Anyway, continuous integration has come up big in the last decade. Test your code before you even check it in. Configuration management, basically setting up virtual machines, setting up, setting up specialized environments that are, you can set up a bunch of specialized environments for testing. This is great. No, don't longer have to have a room full of machines. You have a room full of configurations, which is great. And formal methods tools. Formal methods tools have been becoming a lot more apparent in the last couple, 3 years, as again, CPU cycles get cheaper. When I was in college, formal methods were a big, big deal. I was fortunate enough to attend a lecture by this guy who has no vowels in his name. His last name it was Edgar Dijkstra, who came to UCSD when I was there. And he gave an hour-and-a-half discussion about some little program that he was asked to. Actually, it's a program fragment, some algorithm that he was asked to improve. And he spent the first 45 minutes of the talk proving things about the problem. And once he had proven several things about the problem and identified several invariants, he wrote a second version of this routine. It was like about a third the size and many fewer operations, much faster, much smaller. And I could, squint my eyes and say, okay, I see how you got from there to there. And then he did it again, proved some more theorems and found some more invariants and produced a third version. And I just looked at it and said, I got no idea how you got there. But they were always impractical because the manual versions, doing it in your head was really, really hard if your name was not Edgar Dijkstra or I don't know how to pronounce his first name. It's not Edgar, but it's something. Esger, thank you. Or Niklas Wirth, or one of those guys, people who win Turing Awards, say. And doing it algorithmically was just way too slow. But step back to CPU cycles get way, way cheaper. And it's now practical. I'll give you a concrete example here. Anybody here work on the LLVM optimizer besides Chandler? People in the back. I had a nice talk with a friend of mine who works on that and last week. And he talked about a proof system, not a proof system, but a set of software called Alive2, which uses formal methods to verify the validity of LLVM IR transforms. And his comment was, if you have an optimization that you wish to commit to LLVM, you're expected to attach your Alive2 analysis to your pull request. And he said, if you don't have one, it's not saying that your pull request is not going to get committed, but it's going to be a lot more work. So formal methods are becoming much more of a thing. Okay. AI. I'm going to kind of use AI as just a general catch-all term, ChatGPT, large language models, all these things. And this is not really the last decade. This is really like the last 18 months. And as I was preparing this, I realized this is not a talk that's going to age well, but it's probably going to be outdated next week. So this is my one chance to give this talk. What can AI do for you? It can write some code. It can take a description and write some code, some amount of code. Large amount of code, I haven't seen too many really large amounts of codes, but small to medium-sized chunks of code. Anastasia gave a real nice demonstration of that in her keynote on Monday morning. It can write tests. There have been lots of articles where somebody says, here's some code, and pass through it at ChatGPT and say, write some tests in the style of bum, 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 bum. And it spits out tests. You look at the tests and you say, wow, it just did a lot of the really boring work. It's like, I can see more tests that I want to add, but 90% of the tests are just right there, and I can copy and paste them into my test framework, and great. Summarize code. It could give you an idea, give you a summary of what this code actually does, or as Anastasia demonstrated on Monday, it can generate doxygen comments for your code. Now, you really want to look at this because it just might make something up in the section of the description of the code. But still, a lot of the generating doxygen comments and so on is really boilerplate. And if you can automate a big chunk of that, that's a win. Improve code. People have been throwing chunks of code at ChatGPT since about day 0. Even previous versions to see what can happen. The famous one was somebody found through ChatGPT a way to improve intrasort slightly, but still, it's an improvement. And a lot of people have looked at that code for a lot of time looking for improvements. Or can try to use built-in algorithms and so on. Just this week, I became aware of programs that are not programs, but projects that attempt to decipher compiler error messages using ChatGPT to give you an idea of doing root cause analysis. Your program failed to compile because you have a period here instead of a semicolon. When you do that, you get, if you're lucky, you get 30 lines of error spew. If you're not lucky, you get 200. Depending on where you do. Do it in the middle of a template definition and see what happens. Interestingly enough, there's a lot of research going on in this area. And there is a proposal out and that some people are trying to standardize across compilers called Serif, I think it is, S-A-R-I-F. Don't ask me what don't ask me what the acronyms say for, but yeah, standard analysis, something. Basically, the idea is that when you get a compile error, if you have Serif enabled, you don't get just a spew. You get a structured dump in JSON format that you can, that basically you have nesting on your error messages, and so the idea is that you can have a tool that provides a better experience than just looking at 125 lines of template whatever, because you forgot to define a stream insertion operator for your type, say.
And compiler output's not a stable, compiler output text does not have to be a state or reverse compatible API.
Okay.
You know, like it's all regexes right now, right? And that's not great.
Yes, I know people can do things with regex to clean up the compiler outputs and help it make it easier to understand. I was just talking to Kurt actually at the last break about this, because the senders and receivers, when you make an error doing senders and receivers, you get the most amazing error message, amazingly large that is. But today, Sea Lion can do this. Anastasia gave me a nice demo. And also there's an open source project called CY out of some college in Massachusetts that is doing this kind of thing. Basically, you pipe your compiler output into CY, and it spends a little of your money, and a ChatGPT API key, and it spends a little of your money to give you a message that says, oh yeah, this dot here, this should be a semicolon. That's only going to get better. And I suspect that actually when more compilers start doing serif output, at least have an option for serif output, these things will become even more effective. Cy Brand, the Microsoft MSVC evangelist, gave a talk about structured, improving diagnostics using serif and some tools in Visual Studio. I haven't watched it. It was on Tuesday. But I Googled up, structured compiler diagnostics. That was the first hit. April 30th, 2024. ChatGPT is another thing from Emory Berger and at this college in Massachusetts that I can't remember the name of. Same guy as CY. Your program crashes and you're running GDB, you can say, why did this crash? And it'll look at, using GDB or LLDB, it'll look at it and say, gather up some info and send it off to ChatGPT and see if ChatGPT can tell you why. Open source, you can see what they're doing. Yay. Okay, anyway, Emory Berger is the guy named, and he gave a talk, a really nice talk at CppCon last fall. It's a 30-minute talk. It's well worth spending 30 minutes, or if you're impatient like me at 125%, 25 minutes. Anyway, I'm sorry?
Not 2x.
Things that don't require a lot of concentration, I can listen to at 150 or 175. But this was something I wanted to think about as it went along. So anyway, all right. I've just spent, better part of an hour talking about the past. Let's talk about the future. There's my talk about the future right there. This quote has been attributed to Niels Bohr, but there's apparently a lot of controversy about this because it was attributed to him after he died. Some people think that this was Yogi Berra. How many people here who don't know who Yogi Berra is? A few, not very many. He was a baseball player. He has the interesting distinction of being on more teams that have won World Series championships than anybody else. That happened 10 times. There's a picture you can go search for of him holding up his hands. He's got World Series rings on every finger. And he was well known for saying things that kind of didn't make sense or self-contradictory things. Somebody asked him about a nightclub and he's like, yeah, nobody goes there anymore. It's too crowded. Right. It ain't over till it's over. Thank you. But anyway, this kind of fits into that, especially about the future. But I'm going to try, okay? Some people on like quote history or think this is an old Danish proverb. It could be. Niels Bohr was Danish. I don't know. Anyway, so slide 1, the obvious bits, okay? I don't think we need to spend a lot on this slide. These things are duh. Every new advance in software will be heralded as AI. Okay? I have a friend whose brother is a professor at Stanford. He has a grad program for computer modeling. They model all sorts of things. But what I learned a couple months ago was that the grad students in this program, as part of their thesis work, they are more or less expected to use 1 million CPU hours during the development of their thesis. That's a lot of computing power. CPU cycles will continue to get cheaper. Compute farms will continue to get bigger. 1 million CPU hours in what? How long does a PhD program take? Lisa? Come on, you got a PhD, I don't.
7.5 years?
7.5 years, okay. Still, that's 150,000 CPU hours a year, 130, something like that. That's a long time. I mean, that's a lot of CPU hours. And to give you an idea of how fast, how much CPU cycles will continue to get cheaper, faster, whatever, when I was working in the 1990s, I was developing some stuff to do operations on single precision floating point. Okay? I wrote a routine. We can think of it as like FP classify. Okay? It took a single precision floating point and returned several enumerated values. Was it 0? Was it positive? Was it positive infinity, negative infinity, negative number, not a number, or any one of several not a numbers, and so on. You think of it that way. And I was looking at this, and I was thinking of this, and I was talking to my coworkers, and we were talking about what's the best way to test this? Should we pick a few interesting values and do that? Well, sure. And then I said, jokingly, oh, come on, there's only 4 billion single precision floating point items. I'm just going to test them all. And we all laughed. But I coded it up, right? And I had a pretty hefty desktop machine at the time. This was almost 30 years ago. And I tried it. And you know what? My routine was correct for all of those 4 billion values, which was quite satisfying. But it took 2.5 hours to run. So this is not something you're going to do on a regular basis. So last week, about 3 weeks ago, I took my 2023 MacBook Pro and coded that up again, although I just used FP classify instead of the routine that I don't have the source code to anymore, and tried it. Does anybody want to get a order of magnitude guess of how long it took?
3 minutes. Less than a minute.
Okay, I saw 3 minutes and 10 seconds and less than a minute.
1 second and a half.
2.6 seconds. So from 7,200 seconds or 8,000 seconds to 2.5 seconds in 30 years. CPU cycles are going to, for a computer that arguably costs less, both in actual dollars and in constant dollars, it cost a lot. In constant dollars, cost a lot less than what I had in 1995. 8,000 times faster. And this is a test that runs on a single core. Okay? The fact that this thing has a dozen cores in it is not relevant to this test. CPU cycles are going to continue getting faster. Excuse me for a second. Sorry. I think I'm coming down with a cold. Okay, anyway. Let's move off the duh slide on the things that are. Static analysis will continue to get better, okay? Clang-Tidy is really a framework for writing small static analysis tools, but bigger static analysis tools will continue to get better. Xcode has actually a fairly nice static analysis stuff built in. Other IDEs do too. And then there are large commercial products that will do static analysis. And those are almost all CPU bound for large projects. They're going to, CPU cycles will get cheaper. They're going to be able to do more intense analysis. Lifetime analysis. Lifetime analysis is a thing that is looking very promising. Language-aware tooling will continue to improve. People, be able to say, you fill in, the easy part of that, of course, is just, starting from templates. I need a class that's movable and not copyable, named foo. Bam, there you go. But more of not even Clippy. Let's not go with Clippy. But, somebody puts up a warning, says, here, you've forgotten this here, or something like that. Formal methods will become easier to use. Formal analysis, formal proofs, because CPU cycles are getting cheaper. This is not rocket science here. This is easy. These are the easy predictions. Okay. More and more tasks will be automated by AI. Again, this is not, this is AI is the marketing blurb of the past year and of the next 2 years. Of course, everything's going to be AI. But what does this mean? It means that larger and larger tasks are going to be able to be automated. More and more tasks will now be assisted or automated. CY is a great example of this, but that's just, I'm not touting this as a be-all and end-all thing. It's an example of the kind of tasks. Writing good prompts will become important. It's a skill you can improve, much like writing search queries that you type into Google, Bing, Brave, whatever. I've watched a lot of people type things into Google, and it's definitely, choosing your keywords, choosing your format gives you a wide range of different outputs, different results, some of which are arguably much, much better than the other. This is a skill you can hone. Writing good prompts will become a skill that you should practice. Question for those of you who are using ChatGPT or other large language models for this, do you take the prompts that you use to generate your software, your tests, and check them into your source control system so you can do them again, or you just throw them away?
They're not stable.
They're not stable, but at the same time, do you want to know where this came from?
It was wrong in the first place.
If it's wrong in the first place, you don't check it in ever, right? You don't check the code in ever. Anyway, there will be a lot of things that I haven't thought of, okay? I know that. There are things that people are doing that will amaze me, that will come out while I'm driving home. Not tomorrow or Monday or something like that. Somebody sent me a comic strip from 2018. You know what the industry term for product specification that is comprehensive and concise enough to generate a program? It's called code. That's starting to be not the case anymore. Just starting. And we'll be down that road. The specification, when I worked on libc++, I had an advantage over many, many people. I had a written spec. Okay, that was complete. It wasn't perfect, but I had a written spec, right? It was yay thick. And many people in this room had a hand in writing it. Most of the time, how many people actually work in that kind of environment where you have a written spec for all the stuff you're working on? Anybody? I see a few hands, yeah. People working in the defense industry. Where's Jeff? Jeff blowing up satellites? Oh no, not blowing up satellites, launching satellites.
What I was going to say is, I think that Michael was
Right. It should look kind of like this, something like this, or yeah. I agree. There are lots of specs that are not comprehensive and precise enough to generate a program. You know, at the end of one of the Star Trek movies is like, where do we want to go? That way. Yeah. What do we want? We want a program that does foo. Okay, how could it do it? Well, that's for you to figure out. But yeah, this is becoming less true. Okay? It's still mostly true, but it's less true than it was a year ago, and it's probably less true than it will be a year from now, especially for small projects. Okay. Here's a couple of examples illustrating this point. The first one, prepare a pull request against boost unordered, implementing the transparent try and place methods specified in blah, 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 include tests. Okay, this is a prompt that I would not be surprised to find that something like Copilot could do in the next few years. Okay, 2363 has formal wording in it. Okay, boost unordered has unordered map and unordered multi-map, and you could do that. Okay. I would be surprised but not shocked if Copilot could do this today. I don't expect it can. Sorry?
ISO's not a complete spec, though. You can't get a pull request from an ISO spec.
You can't get pull requests from what?
An ISO spec is not is undefined behavior and implementation defined behavior, right? Like maybe check. Maybe AI can fill in some blanks or something, but like I think you're gonna have to walk it through a bit.
Could be. Could be. I mean, I recently implemented this, not in boost unordered, but in a different code base. And this was the kind of instructions I could get. This is, in fact,
I suspect throws up its hand intentionally in a lot of spots.
yeah, it could be.
You'll figure it out.
Like I said, I don't think this would work today. It would not surprise me to learn that in the near future this would work. The second one, customers reports that the layout of the master reports is messed up when it's printed on A4 paper. Prepare a pull request against something to fix this. I think it would be a long time before we get something like that because of imprecision like messed up and so on. Jeff.
I mean, I agree with Brett in a certain respect, but on the other hand, I would say that, because of the work you did and some others helped, but largely yourself in the past cycle with the standard, right? What a constraint and what a mandate and what those things actually translate into code. It's not magic, right? Like they're the implementers actually kind of know what that means and so forth. Now, admittedly, there's one big hole, and this is where we have big trouble all the time, and that's when we say expression equivalent to blah.
Yep.
That means about everything about that other thing.
Right. Or as if by, or as if by.
We try not to say as if by.
Okay. See, I'm a little out of the loop. But anyway, I really want to point out that I think one of these will be the kind of thing that somebody will be able to do soon, and one of these is not. Because one of those is very precise and one of them is not.
We need a PhD student to actually go and do this. Now, the other thing would be, can't we go the other way? Can't we have, a code base, like, one in Project Keynote, and then generate the standard ease?
That would be cool. He's saying, if we have a proposed addition to, say, the standard library, and we have an implementation, could ChatGPT generate the standard wording? That would be very cool, because writing standard wording is hard. I suspect that's farther out. But that depends on who gets interested in doing it, and who starts investigating it, and who starts pouring resources into it. I don't know.
I mean, there's one really big unsolved problem with this, which is, what is the relevant context, right? That
Yes.
requires embodiment, which LLMs don't have.
Not yet.
Not yet. We'll see. I mean, I have been surprised several times. Okay, here's an example of something that's not a development tool, thing, but it caught my eye. This is an article from Lake Forest University, which is, I don't even know where, probably Chicago. I think there's a Lake Forest in Chicago. But this person, this young woman, as a senior, they have to do a senior thesis. So her senior thesis was to help herself get a job. And she said she applied for 500 jobs, basically job postings on LinkedIn. And what did she do? She wrote some software that scraped LinkedIn, identified keywords, and then uses ChatGPT to tailor her resource, or tailor her resume for each individual job posting. Uses ChatGPT and Google Bard. And she said her experience was that the customized resumes got about 15% more callbacks than the generic resume. This is not a software development thing. This is, thank you. This is just an example of the kind of things people are doing. And this caught my eye mostly because people who write job postings on LinkedIn and in HR departments, they have software to screen the resumes, screen the ones that they doesn't have the things that they want or doesn't have various keywords. And so this is just kind of evening the playing field. So I'm going to customize my resume for you. Anyway, one more point, and then we'll open it up to questions. I'm seeing a kind of a bifurcation in software development, and I wanted to throw this out for thoughts, and then we can have comments about it. Two kinds of software, and it's really not two kinds of software, it's a spectrum, but still. The first one is what I call one-off software. You write software to solve a particular problem, and when it's done, you pick it up and throw it away. Okay? You want to do some data analysis, you want to gather some, scrape some stuff off of the web for a newspaper article or a blog post you're doing, school assignments. Data conversions, I have a chunk of data, I have a megabyte or 500 megabytes of data that's in CSV, I need it in JSON. That's a 10-line Python program. If you put that into ChatGPT, it will probably spit out that 10-line Python program. Are you going to check that into source control? Are you going to maintain that for years? No, you're going to run it. You're going to look at the results. You say, yep, that's what I want, and you're going to move on. Source code refactoring projects. Once you've refactored your source code, do you still need that tool, that specific tool you've generated to do that specific refactoring? I don't think so. People use various things for this. People do data analysis. People use spreadsheets, and then they just don't save the spreadsheet. They maybe use R, and so on. And my expectation is that the portion of these programs which are written by a large language model is going to increase over time. And more of these will be done by quote-unquote non-professional programmers. We can have a long discussion about what is a professional programmer. I don't want to go there. I don't want to quibble over details. I want to just kind of point and say, okay. The other half is long-term software, which is what most of the people in this room I think of when they think of software. This is what they think of. Software written to solve ongoing problems, libraries, developer tools, business process software. I had a discussion with somebody the other day. I said, really? Banks and insurance companies are really software houses. They run custom, that's what they live and die on is software. They run software they purchase, they run software they've developed in-house. The ones that actually are more cognizant of the fact that really they're software houses are going to be more successful. Business process software, process control software, run an oil refinery or something like that. And many others. I'm not saying this is an exhaustive list. But these are the kind of things that we think of software development. These will be affected, my opinion, these will be affected by AI, but to a lesser extent. You won't be able to say to ChatGPT, I need the source code for a C++ compiler. Not soon, at least.
Here's the standard.
Yeah, here's the standard. I need, right? And a standard library implementation. On the other hand, you could probably say, here's a chunk of code out of LLVM. Can you improve this code? You know, in context, there's the code around it. I could see that happening. Other things that, you know, fall into this long-term software thing. Jeff lives in Chandler, where there's a whole bunch of self-driving cars. Some of you live in San Francisco, where there's a bunch of self-driving cars. Those are long-lived software projects. SpaceX is a software house and a hardware house. But it would not surprise me to know that they're looking at using something like this to help improve their software. Anyway, that was my point for thought. Tools are going to get better. They're going to be very different in the next 5 years. And I don't know where they're going. I mean, these are really, really baby steps. These are like almost linear interpolations. And I don't think we're in the portion of the large language model curve that is linear. You know, I think adaptation is going to look like this. And I don't know where we are, but I'm pretty sure it's down low. Anyway, thank you. And let's see some questions. Fyodor.
When we train people to write long-term software, they mostly write throwaway software as a part of their learning. If that part is getting displaced by AI to a much larger extent, how do we train people to write long-term software?
That's a great question. I mean, I always hated that when I asked questions and I got that. That's a great question. But it is a great question because it's not something I'd thought about. And that's a problem, is because, you know, there's an old joke about this, right? Good judgment comes from experience. Experience comes from bad judgment. And if you cut out the opportunities for people to make mistakes, how are they going to learn good judgment? And I don't know. Certainly, I have seen people, you know, out of college who never had a chance to learn bad judgment.
No, don't worry. Mistakes will be made.
Yeah, I know, but we would like them to be not, you know, 7, 8-figure mistakes. You know, not be catastrophic, not take companies out of business. Of course mistakes will be made. I make mistakes, and I've been doing this for a long time. I have plenty of bad judgment I have exercised, and I'd like to think I've learned from that. But that doesn't mean that I never make mistakes. So I wish I knew. That's a really interesting question for people who are bringing new people into their teams, especially like new college grads or, you know, people who just graduated from grad school or something. Gaspar back there.
We're gonna have about a 5-year warning on this one, because if we just look at the Illustrator industry, because entry-level illustrators have a hard time getting work right now, but, you know, high-up illustrators that are established will have a problem because they are selling their judgment, not their skills.
Right. But newbies is a generic term.
Yeah.
You know, they don't have reputations. They don't have bodies of work that they can point at.
Yeah, but Midjourney, you know, has been out a while longer than coding helpers have been. So, like, we can look at those industries and see what happens. And we'll see what will happen to ours.
Something like maybe the world a little bleaker for coders, but software engineers are probably the lane.
I mean, but software engineers are not.
Okay, one at a time, please. Yes.
So the way I see it, and I wonder if you agree or what's your take on it, is that there are tools that sort of like solve the problem for you so that you can just forget about the entire thing, like maybe Git is one of them. Where before we had it, every person needed to have their own system, and now we just don't think about it. Also for GitHub, like pull report system. And then there are other tools that just give you information, like debuggers or the current state of analyzers, just give you more information so you can, and then you need to decide what to do about it. They don't, they sort of like increase the amount of information that goes into, or increase this level, but not hide away things that are considered solved. And I would hope that more tools or more new tools will be of the second category this categorization?
Well, I mean, I don't think of, I mean, I think you're correct about Git only in the very narrow point of people are not inventing many new source control systems anymore.
Check out JJ.
Many, I said many, I didn't say any, but JJ, huh? I'll check it out.
Like GPS navigators means that people don't think about how to keep track of a route.
They don't. Good. That's a better example because Git is something people use, but you have to learn to use it. Late last year, I taught my wife. Hey, Lori, how you doing back there? How to use Git for one of her projects. It was a success, but there were some rough spots. Anyway, and the other half is just tools that give you information and you decide with. The problem with the large language models, what people are applying for, is taking that information and trying to draw conclusions from it. And that's where the big thrust of AI is going.
I think you misunderstood my point about software engineers. Like the hard part isn't even like understanding the output, is convincing someone, like it is deciding to make a sanitizer in the first place, and then when you have one, to convince people that it's something that's worth their time. And large language models can't do that.
No.
The boilerplatey, hey, sir, this is cool, 3 bullet points, and it's not convincing because it obviously comes from a dispassionate place. And like what we do is as a fundamentally human endeavor, and with that we're communicating with large groups of people about ideas and how conceptual sharing concepts. And I don't think that I'll be way to that place per se. It can help you like write your essay better, but it's not going to tell you like what your thesis is, right?
Right, I would hope not. Although, how many people know who Tyler Virgin is? Vergin, V-E-R-G-I-N. Anybody? Okay, Google up, plug into your search thing, your search engine of choice, spurious correlations. Okay, he has a website, his section on his website is called spurious correlations. He has 50,000 different data sets, and he mines them for things that correlate really well. And then he has a page for each of these pairs that correlate really well. And the page includes a graph of the two things, showing them going up and down. And one of them was, the last one I looked at was, I think, number of students graduating with masters in statistics compared with Google searches for dollar store. They correlate really, really well. And then he shows you that, he gives you a link to the data set, he gives you the Python code that makes the graphs, and then at the bottom there is an explanation from ChatGPT about why these two things are related. And then an academic paper generated by ChatGPT about the relationship between these two things. It's a wonderful site to spend a couple hours on. You'll have a great time. You will have a great time. But at the same time, is this useful? No, not at all. But it's very much the kind of things that people are doing with AI, just as a, look, it can really do, it can do silly things. And I have used this site before to convince people that correlation does not imply causality. Yes, Jeff.
So as a senior software engineer, I would argue that I feel no fear from the large language models. Because my view of the software engineering is my most valuable skill is when I can talk you down from the ledge from writing code.
Okay.
It's an absolute negative because you can never see the code that was never written because you backed off of a stupid idea and did something smart.
You know when your AI merging your pull requests,
Right.
right?
Although, I had a friend who was at Google for a long time, and she said to me once, she said, yeah, it was kind of weird the first time I was asked to review a pull request which was generated by a program. This was done as part of a software refactoring project, right? They were doing refactor, but the refactoring program generated a pull request, old, new, and then they sent it out for review.
Among Us hasn't generated pull request via regex.
I haven't. Seriously. I saw a 450K regex as when I was younger, and it scarred me for life. I mean, it took me a day to get that down to 50 characters, and then I could actually figure out what was going on. But it took a whole day to get to 50. Anyway, other questions? I'm not seeing, how are we doing on time? We're over? Okay, yes, sorry.
With regards to generating code, does anyone find it easier to read code than to write it?
Ooh, does anybody find it easier to read code than to write it? Wow. Personally, sometimes, and other times not. Yeah?
If the code is adversarial, no.
Yeah.
Oh, I can feel comfortable approving a PR an order of magnitude faster than I can write it.
Yeah.
What if it's
Especially
written?
if the unit tests pass.
Right.
What if it's written by an algorithm that has been trained to deceive you into thinking it's good code?
Right, like adversarial code.
And then we're back to Ken Ritchie's C compiler. Yes. All right. Katie is looking at me and telling me we're over our time. I'm going to give the microphone away and walk back up to the pavilion there, and I'll be happy to answer more questions up there. Okay? Thank you for listening.